So in part B, we are told that Catalina and Daniela cannot sit next to each other, but Alvin and Bobby must still sit next to each other, and we need to find the total number of ways the children can be seated. So what we can consider here is that from this number, we can subtract the number of ways Catalina and Daniela can sit together. So the number of times or the number of options when they sit together. If we find the difference of these two, we will find the complementary event, which is when C and D don't sit next to each other. So let's calculate how many ways C and D can sit together. So the first case is when A and B sit in these first two seats. So again, they can sit as A and B or B and A. That'll be 2. And then C and D can sit in 1, 2, 3, 4, 5, 6 different places. And again, they can sit as C and D or or D and C. So that's just a multiplier of 2. And the rest of the students can sit in any way they want. And again, we have 2 rows. A and B can also sit here. That would be an identical case. So this will be 34,560. And then we can have the second case when A and B sit in the middle. So over here, again, it can be A and B or B and A. Now C and D can only sit in 5 places here. So that's multiplier of 5. Again, it can be C and D or D and C next to each other. The rest of the students still have 6 and we still have 2 rows. This is 28,800. And just 800. And then we can see that A and B can also sit over here, but that's just the same case as when they sat here, as it's symmetrical, or they can sit here, but again, that's just the same case as when they sat here, is because it's symmetrical over here. So we can multiply these by 2, and we will find the total number of ways. And if we add these, we will find this is 126,720. So this is when C and D are always together. So the times when they are not together will simply be, well, we can simply subtract these two numbers. So they are not sitting together in 518,400 different cases.